and welcome to another Unity tutorial. We're following on from the previous Minecraft example where we created a Minecraft landscape. This is part 2 where we're going to look at creating some caves in the environment. So this is what we've got so far. We've got a first person controller that we can walk around in our Minecraft world, and also jump. And we can dig. So we're going to extend the code that we've already created to make automatic caves in this environment. First thing I want to do though is to create some clouds. I want to do that so that we can actually lift our landscape up. So if you remember back, the landscape we've got is 128 by 128 by 128 blocks. But the Perlin noise, which is generating this landscape, is only creating the landscape up to about level 20, which means that we've got all of this space where there's nothing and then not very far to dig down before we hit 0. And I can actually dig, and you can see from there. And we want to make this a lot deeper. So that just means picking up our whole landscape and moving it up. But first, let's add some clouds across the top to the very top layer of our array so that we know where the top is. Okay, we know that the index of the top is going to be 127 because that's the size of the cube. But it's just nice to be able to see something and have a visual reference. So I'm going to do that. Okay, so let's just stop playing this. Now, the method I'm going to use to create these clouds is something that we call a crawler. And a crawler is a really simple little piece of code that basically starts on one coordinate and then randomly selects where it's going to go next. And then it moves, and then it randomly selects where it's going to go next and moves there. So it sort of ends up drawing a little trail behind itself. I've got a quick demo of a crawler that I quickly created in processing for you to have a look at. You can see it in action here. So it started in the middle of the screen and it just keeps deciding where to go next using the random function. And so each time you run this, you're going to get a different pattern that's created. We're going to use the crawler for creating clouds, and we're also going to use the crawler later on for actually digging out the cave. Okay, so let's get started. The first thing that you need to create clouds is a cloud block. I already created a cloud prefab block here. So all I did was I duplicated, I think, the snow block, and then I put a white material on it. And then I renamed it to cloud prefab. That's all I did. Now, while you're doing this, making this new cloud prefab, you might want to also make a diamond prefab, which I also have created just by grabbing a diamond texture from the internet and just putting it onto a cube. So one's called diamond prefab and one's called cloud prefab. Okay, I'm just going to delete those out. Now the code that we've been using is called generate landscape. Let's go back into there. So nothing's changed since the end of the previous tutorial. To create these clouds, we need to bring in the cloud block as another game object. So I'm just going to copy this code and put it there, and let's call this cloud. Okay, so that will then, if we save that actually and then switch back to Unity, look for our landscape, and in the inspector we're looking for this cloud block exposed variable. And we can grab our cloud prefab and dump it in there. Okay, so the script now has access to that. We're now going to add a function that's going to create clouds, and it doesn't really matter where we put this function. So it has to be outside of the other function. So this is the entire start function, and here's our create blocks. Let's put create cloud just in here. All right, so I have already written this function, which I'll copy and paste into here for you. Okay, so it's called draw clouds, and it accepts as input the number of clouds that you want to generate, and also a size, cloud size, so you know how big those clouds are going to be. It then has a nested for loop. The outside for loop loops around for the number of clouds times. That will give us each of our 10, 20 or whatever clouds. And then there's another for loop that loops around for the size amount of times. And this actually creates the cloud. So the bigger C size is, then the more this will loop and the more cloud blocks that will be created. Okay, so we then need to initially set a random position in the sky for the X and the Z position of the cloud. Remember, for the height, it's going to be set at 127, which is 1 minus our height of our three-dimensional array that's storing the blocks. Because the array starts counting from 0, it means that the top index will be 127. It won't be 128. So to create two random values somewhere in the sky for the X position and the Z position, we can use the random.range function and pick out a number between 0 and width. Now the random.range function gets values including the first value up to, but not including the last value. So in this case, this would be 128. So it's going to get you values between 0 and 127 inclusive. It's very important to remember that it doesn't include this last value, and therefore if you want things to go right up to the edge, you need to ensure that this is slightly bigger than what you are hoping for in those random numbers. Right, so that takes care of our starting position for our cloud. Okay, we're then going to create our block pos again, which will be our X and Z positions, and we will use height -1, which is going to put these blocks right at the top of our sky, and then instantiate our cloud block at that position. Okay, this debug line is something I have left in there. I'll just get rid of that. You don't need it. And remember, we've got our visual world of blocks, and we also have our three-dimensional matrix. So we also have to populate that with the block type that we're putting in that position in the world. We've got sand, grass and snow so far. So our cloud block will now be type 4, and true means that we're drawing it because the clouds aren't being obscured by anything. Okay, so we've done that. We've created a block. Now, before we loop around again, we're going to update the X and Z position to somewhere close by in a neighboring cell, and use that to draw the new block. Now, sometimes our little crawler might go outside of our array, so go outside of the range that we've got to work with, in which case we're going to set it back to the very middle of the sky. Now, you could do things like setting it back to the closest border that it's just gone out of and that sort of thing, but that was just too difficult to think of right now. I'm just setting it to the middle here. It's up to you where you set it. So this works fine. So this is our draw clouds function. Now, next, we need to actually run this draw clouds function. So what we're going to do is go up to our code, find where we're drawing our world, which is in the start function. This for loop is where the world is being created. So after we've created the world, we're going to draw some clouds. And we're going to draw, let's say, I don't know, 20 clouds, and we want them to be big. Let's make them 100. Okay, so save that. Then switch back to Unity and run. Right, now you can see there's some clouds, and we've fallen a long way, and you can see now the great distance between the top of our terrain and those clouds. Okay, they're not perfect, but you know, they're pretty quick and easy to create. So you can make them bigger and you can have more of them by changing those parameters that are going into that draw clouds function. Now, to lift the height of the landscape up so that we have more dirt and ground underneath, it's quite easy. And it's only 2 lines of code. So go back into our generate landscape code, and we're going to go up to the top of the class and create a new integer variable in here. And that's going to be a public int. So it's public, which means we can control it from the inspector. Height offset. And we'll initially set that to say 50 because we want to lift it up a fair bit. Probably could even go to 100. I'm going to start with 100. Let's see what happens. Right, so that's our height offset. This is the value that we want to now add to the initial y, or the height of our blocks. So just working down into the start function where our height is initially set using Perlin noise, we're then going to add the height offset value in there. And that's it. So that will lift our landscape right up. So let's save it and see what's happened. And then I'll go up to 100 blocks to what it usually was. Okay, so what's happened here is that your first person controller has been created below the landscape instead of above it because the landscape has moved. So you need to keep that in mind and move your first person controller up before you run it again. Okay, so oh, now we're way up in the sky, even above the clouds. Okay, so there's our clouds. Oh, we're quite high here, aren't we? I guess that's not too bad though. Let's go with that. It means we'll have a lot of ground to start digging out underneath here. You can see that the entire landscape is snow, which is not unexpected because we're now up very high. And remember, we set all those different levels for the type of blocks that we would get. Okay, so we've got some clouds and some snow. Probably a good time now to reset the levels at which our texturing happens to align with this. So because we lifted up the landscape by 100, why not also lift up these height values in create block that determine whether snow, grass or sand get done? So let's add 100 to the height range for snow, and let's add 100 to the height range for grass, and everything else below that is going to be sand at the moment. So save that, and let's just run it to check that we've got some different textures happening. Yep. Okay, so oh, I landed on a cloud. So if I just walk off the cloud, okay, and you can see we've now got all of our textures back. We've got the snow up the top, the grass in the middle, and the sand down the bottom. Before we create a crawler to build some caves for us automatically, we're going to add some diamonds in at a particular level so that we've got some interest when we start digging. The first thing to do is to get the diamond prefab instantiating at the right level. So we've got our diamond prefab created. Let's go to generate landscape again. And I'm going to create another public game object, and we will call that diamond block. Like that. Save it. And then if we switch back, select our landscape, we can set that diamond block exposed variable to our diamond prefab. Just drop that in there like that. Okay, go back to our code. We're now going to use this diamond block down in the create block function. Now, there's probably better ways of putting this code in than I'm going to show you, but I want to show you in a way that it's really obvious what's going on. So this is going to create our generic landscape with snow, grass, and sand. After we've done that, we're going to put a little bit of code that before it's sort of finished with that particular block that it has created, it's going to go, oh, if this block is between this level and this level, then we're going to set it to diamond instead. So we'll add another if statement. If y is, let's say, if y is between levels, if we're digging down from, say, grass from 100, let's say we don't have to dig down too far, that we're going to set diamond to be between, let's say 70, and y is less than 80, then we're going to create some diamond in there. Now we can just use this code, put it in there, and we will change our block creation number to 5 for the type, because we used 4 for the for the clouds. So this is 5. If we're in create mode, we're going to draw a diamond at the position, and then we're also going to set the array, three-dimensional array's position to a 5 that has been created. Now, this is going to work the same with the other blocks. If it's underground, then it's not going to be created. But what I want to do is force it to be created so we can see it. So I'll just comment that out. And I'm just going to set this to true. So now when we run it, we should be able to see that layer of diamond having been created. Right, so running it, it's thinking, generating the landscape. Okay, let's just pause it and have a look. And we can see very clearly in the scene, whoa, there's all our diamond. That's quite a lot. And it's going to take a fair bit of digging down from here to get down to it. So we could move it up so that we will see it more clearly. Okay, so back in our code in the create block function, we've got our diamond between level 70 and level 80. And as we've just discovered, it's probably a bit too deep. I mean, for the real Minecraft, it's not, but for us, for testing reasons, we might want to move it up a bit. So let's just say that we're going to have diamond between levels 80 and 85. Okay, the other thing we want to do is set the occurrence of diamond with some kind of probability, because you don't just find a complete layer of diamond in the landscape. It happens here and there. So we can actually add some randomness to this with probability, and we can say, like, if it's between these layers and a value of random dot range that's between 0 and 100 returns a value that's less than, say, 10, it gives us a 10% chance that we will get diamond at this level. Now, if I leave create on so we can see it being created again and just save and run it, let's have a look. We should have smattering of diamond. Okay, so here's our landscape. I'm just going to pause that so we can look in the scene at our diamond. So here's the diamond occurring at those layers at a 10% chance, which is still quite a lot of diamond happening. So you can play around with that random value for where you want your different minerals to occur. All right, but let's just leave it at that for now. And you can use this same method if you want to add other layers of different minerals. Okay, so you just replicate this and set the different height values and your percentage values. Right, so let's put if create back into here again, and we will set this value here to create as well, so that these diamond blocks will now operate in the same way as the other blocks do, so that they won't be visible initially until you've dug down to them. Okay, so now we're going to create a crawler to create some caves in our landscape for us. The crawler needs to move throughout our 3D environment block by block in a random direction and destroy blocks before the world is instantiated, before it comes into existence for us to walk around in. Now, the current way that we've coded it is that we have an internal three-dimensional array keeping track of whether blocks are there, what type they are, and whether they're visible or not. And then we have the blocks in the environment themselves. Now, those two things aren't actually linked, not with code. So if we're looking at a block in the array, in the three-dimensional array, we don't have any link back from that position in the array to the block that exists in the environment, which causes an issue when you're crawling through that 3D array and trying to delete blocks. It's okay to delete their memory position in the array, but you've also got to delete the actual block itself if it exists in the scene. So this now requires an awful lot of change to the code, but just bear with me and I'll go through it step by step. So as you can see, I've already got this changed code up on the screen. The first thing we need to do is to change our block class, which is right up the top. And each block object in our three-dimensional array is now going to point to a game object. So this is the game object that's getting instantiated in the environment so that it's got hold of that block, the physical, let's call it the physical block because this is the virtual array. I guess that's a little ironic since the whole lot's virtual, but you know what I mean. So when we create a block, we're now going to pass through the object that gets instantiated if it happened to get instantiated. So if our visible value is true, then we did create an actual block in the environment, and we're going to grab hold of it here. So this is the changes you need to make to the block class itself at the very top. Making the changes to the block class is now going to have repercussions all the way through the code. So wherever block was being used, it was being used without the game object being passed to it. So we need to update it everywhere and look for that. Okay, so the first place you're going to find that is in the draw clouds function, because we create the clouds obviously, and then we create the block for the clouds. So for the instantiate, this is what you will have before, we need to add this in front of it. Instantiate returns an object. We need to cast that to a game object, and therefore we capture it in this variable new block game object. And then when we set world blocks to our new block like this, we've now got new block at the end here. So everywhere in the code where there's this instantiate line and then there's the world blocks creation line with block, this exact same thing has to happen for all of those. Now you'll see the start of this dig mines function down here, and I'm going to talk about that a bit later. So let's just zoom over the top of that. Okay, let's go down to create blocks, and in here you can find the instantiates that were here before. Notice now we've got new block equals game object, and then we've added new block at the end of this creation of the block here. The same is going to happen here and here, and moving down here and here and down again. We've got our create block instantiate here for our diamond that we created before, and then the new block there as well. Now there's more code to come. So in draw block function, there's more creation of the game objects. This bit here has changed a little bit, so you'll want to check this with what you've got in your code, and you can see that the new block is being set to equal the instantiation. Okay, so we've added this line, and then we're putting new block equals, new block equals, new block equals. This whole else statement has been added for type equals 5, which will draw, or instantiate, I should say, our diamond block. Okay, so that wasn't there before. And I believe that is all of them. Okay, and the update function hasn't changed. Right, so that's all of the changes that need to be made to include that new block class. Now let's take a look at the dig mines function that I've added. First of all, I'm going to switch over to my illustration of our block world to give you an idea of what's going on in this class, because in this function, because it's quite complex code. So we're going to create a 3D crawler, and the 3D crawler is going to start somewhere. So let's say it starts here, and then it's just going to jump to the next one, and it's going to start digging down and just randomly digging around at its own leisure for however long we set it to go at. And it'll destroy all of the blocks that it touches as it goes. Once it's done that, we then want to loop through the entire environment and look for these holes. If there's a hole, we're then going to draw these surrounding blocks that are still in existence. And that will give us the interior walls of the mine shaft that you've created so that you will see them. Now, the way that we're going to draw these blocks is similar to the way that we did the draw neighbor when we click on something. The difference being is when we click on a block to destroy it, we draw all the surrounding blocks plus the ones on the next layer up and the ones on the next layer down. With the mines, to make it much more efficient, we're going to loop over the whole environment one row, one column at a time, and dig down in the Y and have a look for any blocks that happen to be empty, such as these holes. And when it finds a hole, what it's going to do is just draw, let's assume this is the hole that it's found. It's easier to see because it's on top. As we're going down through the world, it finds this empty block, and then it goes, I'll draw the neighbours that are on the same level, if they need to be. This one won't get drawn because it's already a hole. Okay, so it looks around itself. And then it would go to this one, and then it's going to look around at the blocks that are around it. And then it goes to this one, and this one looks at the ones on the same level. Okay, that's a much more efficient way of filling in the mine walls without going through everyone and setting up everyone, because at all the different levels, because you're going to start creating blocks over the top of blocks where you don't need them. And we certainly don't want to do that. So let's go back to the code and have a look at this dig mines function. So I've inserted it just after draw clouds. And it uses the same kind of crawler code as draw clouds with, first of all, we've got this number of clouds and the size of the clouds. The same thing with the mines. So we've got how many mines do you want, and also how big, basically, are they going to be. So that's these two values that get passed in to this function. Now, we could also just be digging down one hole at a time and jumping from one block to another block to another block. The problem with this is it's going to dig a really narrow hole, which we won't fit into, and create a kind of like cracks in the environment rather than a mine. So by adding a variable called hole size and then using this triple for loop that we've seen before to dig out a hole that is of hole size. So the crawler goes to a certain block, and then this for loop will dig out that block and all of the surrounding blocks that are basically touching it. And that gives us a bigger hole of this size. In this case, it's 2. So it's 2 on either side of the block, which will give us a cube, which will be 5 by 5 by 5. That will be the size of this particular hole that gets created. Right, and then for each one of them, it loops through and it destroys the block. And then it also sets the position in the world array to null for that block as well. So we've totally obliterated it from existing as a game object in the world and also from existing in our three-dimensional array. Okay. Once we've done that, we then come down and we increment the crawler to go to another random spot. We then check that it hasn't fallen outside of the range of our world. Okay, so you'll see that we're keeping within the hole sizes ranges from the actual edges of our world. If it does crawl outside of that range of the world, I'm putting it right back dead in the middle, just because that's how I did the clouds as well. Right, so this code, all it does is it crawls around and it digs out the hole. It doesn't go ahead and draw anything yet. Okay, otherwise we'd be drawing a lot of stuff we don't really need to be drawing. So let's wait until the hole is completely dug out. And then down here, at the end of the function, is another amazing for loop, which is doing what I demonstrated before. Okay, it's looping through that entire 3D cubic world using the Z, X, and the Y axes, and it's going down, or I should say it's going up the Y axis here, and then it's grabbing all of the surrounding blocks and doing one of those draw block functions on it, which will then fill in all the blocks on that same level for us. Okay, so that is essentially our mine creation function. Now to run it, I've put it up here. It's underneath the draw clouds function, which is inside the start function. Okay, so there's our dig mines. And you can see that I'm going to have 5 mines in this case, and we're going with 500 for the actual crawler size. So that's 500 loops that the crawler will keep crawling for and digging stuff out. Okay, so save that, and let's go back to Unity. Let's run it and see what we get. Okay, you're going to notice it's going to take a little bit longer than before, but it's still pretty fast. And we might not be able to see the mines from on top, so I'm just going to pause and go to our scene here. You can see our landscape. If I just move this around, in this particular case, you can see the mines that were created. So here's the caves that are underground being dug out, and they started around position and then they grew out. They didn't sort of grow downwards. This is all random, so you get different cave systems each time that you run it. Now I'm inside that cave within the scene environment. You can see what it looks like from there, and then we're back out again. So what will happen as you in the case of this mine here is if you dig down from this point here, you're going to hit this cave and fall into it, or however. Okay, so that is how to create caves. I'm just going to run it again so that you can see what it looks like when we get a different cave system. Pause that, and now you can see we've got a different one. You can also see on the outside of this particular one where those diamond blocks have been added at random on that level there. Okay, so that's digging caves, or automatically digging caves and placing different minerals at different levels. I'll just go over that really quickly again, go back to the code and show you where you would change that. So if you want to add different minerals at different levels, you're going to need initially a new block, so a new prefab for your block for what it's going to look like. Then you need to set up where this create block, in the create block function, a range for the levels, which are these ones here, and also a chance. Okay, so a percentage chance. In this case, we've got 10%. That's how you would do 10%. That we're going to get diamonds on that level there. So you would just replicate this for your new block and make sure that you include that block in here. For each new block that you create, don't forget you need to have an else statement in the draw block function that has its type. It needs a new type number. Be sure that you include that as well. All right, I think that's going to do it for now. It's a pretty long tutorial. Thank you for sticking with me. This code will be up on the website, holistic3d.com/tutorial. You'll find it there along with the link to the YouTube video. And that might be easier than typing it all out yourself. If you've stuck with me to type it out, well, good for you. There's nothing like putting the code in yourself, but if you have problems, you can always check for that code there. And in the next tutorial, we might continue with Minecraft. So one of the things we haven't done yet is to actually place new blocks in the environment. So I'll show you how to do that then. Okay, well, thank you for watching.